Hi students, welcome to Preliminary Chemistry and the Energy topic. This is the penultimate video in the energy series. It's number 15, looking at reaction kinetics. Now, one of the important things that we need to kind of realize about chemistry is that there's a lot of ideas that we keep coming back to over and over again. And the first time you encounter them, they can be quite new and quite difficult. But once you've seen them a few times, you've used them a few times, you become more confident in your own ability to process the information and to use these important theories to help you explain the behavior of chemical substances, the easier it becomes. One of the important things that we need to look at just as we finish our preliminary course is this idea of chemical kinetics. Chemical kinetics is basically the study of reaction rates and why certain chemical reactions occur and others don't, and why some types of reactions occur more quickly than others. And there are several different factors that affect the rate of a reaction, and I'm sure by now you have a fairly good understanding of the different factors that can affect the rate of a chemical reaction. The way we explain each of these factors comes back once again to our idea of the kinetic theory of matter, or the fact that particles in any substance are in motion. Some are moving faster than others, and when they encounter other particles of other substances, there can be interactions between them. So to highlight each of these, let's go through these points one at a time. First of all moving particles have kinetic energy. That's a function of the fact that kinetic energy is a half mv squared. So anything with mass that is moving is going to have kinetic energy. Particles in the gaseous phase move freely and more rapidly than particles in the solid phase. Therefore, they have a greater kinetic energy. And this also is a result of the fact that they've overcome the bonding between the particles. They can be chemical or physical bonds, and they're things we've talked about. Chemical bonds include ionic, covalent, metallic, and the physical bonds include hydrogen bonding, dipole-dipole interactions, and dispersion forces. The particles in containers collide with one another. They are moving freely and randomly, so they're going to have collisions with one another. If the collisions have sufficient energy to break the bonds, they react. They'll form the activation complex. They'll have reached the activation energy required to react, and therefore they will undergo a chemical reaction. The greater the number of collisions between reactant particles and the greater the energy of the particles involved in the collision, the greater the reaction rate. So reaction rate is related to the number of collisions and also the amount of energy. So these are the two key components that link into our study of reaction rates or chemical kinetics. The stability of any chemical substance is related to the total energy in the substance. And the energy in chemical substances exists as a potential energy. Potential energy is the chemical energy locked up in the bonds, and kinetic energy, which is the amount of energy possessed by moving objects. Each of these added together gives us a total, which we call the enthalpy of the substance or the heat content of the substance. And these are the things that we need to consider when we're looking at reaction rates. Chemical bonds store the potential energy, or what we might call chemical potential energy, which may become available when the substance reacts. And we looked at that when we were doing our calculation of bond energies. If enthalpy is the sum of the kinetic energy and the potential energy of 1 mole of a particle of a specific substance, then we can use that information to look at how individual substances combine with others, what overall energy changes occur, and how we can quantify those values. And that's what we've been doing for much of this topic. As a side, the branch of chemistry that deals with chemical kinetics and reaction rates is known as thermochemistry, and thermo basically links to heat. We know thermometers are used to measure the amount of heat energy. So if we raise the temperature of a substance, what we're doing is we're adding heat energy to the particles. This increases the kinetic energy of the particles as that heat energy is converted into kinetic energy. It's not going to change the bond energy, it's simply going to increase the kinetic energy of the particles. Svante Arrhenius, a chemist that we're going to be looking at a little bit more in our study of the acidic environment in terms of his definition of acids and bases, explained chemical kinetics by proposing that any reaction would occur if the sum of the kinetic energies of the reactants is greater than the activation energy. So we know from our energy hill that we have a certain amount of energy that's required, which we've called our energy of activation. And effectively, if all of the kinetic energies of the reactants summed together is greater than that, then we will have a chemical reaction. If we add heat, we increase the kinetic energy of the particles, resulting in a higher proportion of particles having kinetic energy. Now, one of the things that's very important to remember then is that temperature is a very important factor that affects the rate of a chemical reaction. So are things like surface area, because we're making the number of particles greater by decreasing their surface area, or increasing their surface area and decreasing their size. This is related to concentration. If we add more particles, then the chances of them running into each other and having some particles with sufficient energy to react increases. So do things like the volume of the container, or which can affect the pressure for gases. We squeeze the particles closer together, they are more likely to react with one another. So these are all very important factors that can affect reaction rates and part of our consideration in chemical kinetics. Thanks for watching.